the last lecture in our Unit 2 weather series. So this one's on severe weather. So the first one on the list here is thunderstorms, which are also known as electrical storms because of their lightning. Warm temperature, moisture, and rising air, which may be supplied by a low pressure system, is what causes the thunderstorm. The cumulus cloud that is forming when there's a thunderstorm can grow into an almost 6 mile high thundercloud, which we call a cumulonimbus cloud, in just 30 minutes. So when you think about that, 6 miles high, 30 minutes, that's a very short period of time for something that becomes so massive. A thunderstorm has a three-stage life cycle, and those cumulus clouds will form from updrafts, which are the low air rising, and then from downdrafts, which is the cold air sinking at the same time. So that warm air rising, cold air sinking, those are your updrafts and the downdrafts. And that's what's going to create that cloud, that cumulonimbus cloud, that can be almost 6 miles high. Then we go into a mature stage, which is when we start having heavy winds, the rain and the lightning. And then normally within 30 minutes after it's hit the mature stage, the thunderstorm begins to fade out and dissipate, and it'll be over with. So here in Florida, our thunderstorms are normally about 30 minutes to an hour, and that's typical. Our storms normally come from either the ocean side or out of the Everglades, and again, that's mainly because we have so much water. We have a lot of water vapor, so we have more thunderstorms than you would see um, in a place like Georgia or Oklahoma or something like that because of the fact we have so much water vapor in the air around us. The strong updrafts and downdrafts within a thunderstorm cause millions of these ice crystals to rise and sink and crash into each other, and that crashing into each other creates positive and negatively charged particles in the clouds. Um, and the difference between the charge in the sky and in the ground actually causes the lightning. In reality, that flash that you see is taking place after the lightning has actually hit. That charge moves so fast that it's moving faster than the speed of light. So what you're seeing in the sky is actually the flash of lightning after it's already hit. Lightning can produce heat of 48,362 degrees Fahrenheit. That's extremely hot, and that's what makes lightning extremely dangerous. You can get lightning burns if you were to ever be struck by lightning. There are more lightning strikes in Florida than any state in the United States. Tampa is actually named lightning capital of the world, so most of their power lines are underground because of this. And there are more injuries in Florida related to lightning than all of the 50 states combined in the United States. So thunderstorms here in Florida are dangerous. So when we say, that there's a severe thunderstorm warning, it's serious. That's why, we take precautions as far as sports, and you have the lightning alarms that go off and things like that, because this is something that's extremely dangerous, especially where we live here in Florida. The next thing would be tornadoes. And tornadoes are defined as a violent whirling column of air that come in contact with the ground. They have a diameter of several hundred meters, some wider than a mile. And wind speeds can reach 250 miles an hour, and that's extremely fast. And some of you guys are like, whoa, that's way faster than in a hurricane. So which one would be more dangerous? Well, they're both extremely dangerous, but with a hurricane, the danger comes with other added factors that a tornado doesn't bring. The tornadoes are strong enough to send cars, trees, and whole houses flying through the air, and they usually last only a few minutes, but sometimes it can last hours. Okay, plenty of people have seen the movie Twister. It's much older for you guys. But it shows different levels of a tornado and the kind of damage that it does. Um, Tornadoes are extremely dangerous, and they'll tell you if you ever are driving and you see a tornado forming, don't ever try to outrun the tornado. Try to find some form of shelter as soon as possible. And if you can't, get into a ditch and lay as low to the ground as you possibly can. Put your hands over your head to help protect your head, just like we do a tornado drill here in school. It's the same concept, um, because you won't be able to outrun a tornado, not when they're moving as fast as they move. When a thunderstorm updraft begins to rotate, that's when the tornadoes can form. So that's why sometimes you'll see that we get severe thunderstorm warnings and then you get a tornado warning or a tornado watch in your area, because the tornadoes do kind of spring up out of those thunderstorms. And that's also why you can get tornadoes in hurricanes. Um, the swirling winds will spiral downward from the thunderstorm's base, and that's what creates the funnel cloud that you see. And then once it touches ground, it officially becomes a tornado. So it's an official tornado when it actually has a touchdown. The swirling air is invisible, but what we do see when we see the tornado is actually the debris that's being picked up. And more tornadoes occur in the US than anywhere else on Earth. The central United States, from Nebraska to Texas, has the most tornadoes and is also known as Tornado Alley. So they see many, many tornadoes, and their tornadoes are very powerful and can level, I mean, they can level schools, and they can happen at any time throughout the day. Florida experiences 60% of its tornadoes from the months of June to September. The most severe tornadoes occur from January to April, though, because of the jet stream being present in the state. So that jet stream kind of dips down and ends up creating more severe tornadoes. Now, remember, 60% comes between June and September. That's hurricane season. But that other 40% where they're more severe is coming due to that jet stream. Florida tornadoes can take place anytime, day or night, and at night would tend to be the more dangerous one, because if a tornado does come, there are a lot of people who are sleeping and are not watching the news to be able to get that tornado warning or that tornado watch to be able to seek shelter. Tornadoes are measured using the Fujita scale. Now it's called an enhanced Fujita scale, and it measures the amount of damage caused by the tornado. So when you look here, this is the Fujita scale going from an EF0 all the way to an EF5. And EF0, there's light damage. In EF1, you have some moderate damage. EF2, you can see the images as we go along. EF3 is more severe. EF4 would be devastating, and EF5 is complete and total devastation, and completely uninhabitable. I mean, those buildings, that same house, is down to toothpicks. There's nothing left. So during Hurricane Irma, we might have had a couple EF0s, EF1 tornadoes that popped up and sprung about, but nothing compared to the EF5 that we see here on this picture. The next one is a hurricane. That's the next one we're talking about. And a hurricane is an intense tropical storm with winds exceeding 74 miles an hour. We all know that at 75 miles an hour, it becomes a Category 1 hurricane. Hurricanes are the most destructive storms on Earth. Typically, they form in the late summer over warm tropical ocean water. And hurricane season begins June 1st and ends November 17th. We've noticed that with rising ocean temperatures, the hurricanes have become stronger and stronger. Looking at Hurricane Irma hit, and it was 4 times stronger, or 4 times bigger than Hurricane Andrew. And for Florida, Hurricane Andrew was extremely devastating. So we can tell that as time has gone on, these storms are becoming more and more massive because the water is getting warmer and warmer. Peak time in Florida for hurricanes is August to October, and a typical hurricane is around 300 miles in diameter, so that means it's 300 miles wide, which is 150,000 times larger than a tornado. So that's why hurricanes are considered more destructive, or the most destructive storms on Earth, along with the fact that you have to take in flooding, storm surge, and wind speeds, and the fact that a hurricane takes a long time to pass through. It'll take several hours for it to move. They move extremely slow. The center of the hurricane is the eye, and it has clear skies and light wind. So really, the eye of the hurricane is not dangerous. It's the eye wall of the hurricane that's extremely dangerous. Again, as warm air rises, it cools and the water vapor condenses and the clouds start to form. And as more air rises, it creates an area of low pressure over the ocean. The air continues to rise and a tropical depression starts to form. Tropical depressions bring in the thunderstorms with winds between 23 to 38 miles an hour, and the air continues to rise and rotate counterclockwise. And that counterclockwise motion is due to the Coriolis effect that we spoke about in our air currents video. The storm builds into a tropical storm when the winds hit 39 miles an hour and is considered a tropical storm up until 74 miles an hour and has extremely strong thunderstorms. When the winds hit the 75 miles an hour, they officially become a hurricane. Only 1% of tropical storms become hurricanes. As crazy as that sounds, given that we've had four this summer that were major hurricanes, it's statistically that only 1% of tropical storms become hurricanes. So, because we name them from A to Z, so out of the 26, only 1% of them will actually become a full blown hurricane. Now, the damage from hurricanes occurs from the strong winds, the flooding, and the storm surge. Storm surge is actually one of the deadliest parts of a hurricane. And while the hurricane is over the ocean, it creates very high waves and pushes those waves onto the shoreline, which causes the coastal flooding, which was one reason why low-lying areas and the eastern coast of Florida and the west coast of Florida had to evacuate the state or evacuate to more inland. Once a hurricane moves over land or cold water, it'll lose energy and it starts to dissipate, as we saw with Harvey and as we saw with Irma. Florida's location leaves us very vulnerable because of our position. We're kind of in the path for any kind of hurricane that develops in the Gulf Coast or any kind of hurricane that develops on the east side, as we saw. And developing storms often steer towards us. Those two YouTube video links that you see there, one explains the Saffir-Simpson scale with a simulation. So if you go onto the PowerPoint, under the PowerPoint section, you could click on that and view that. And then the other one explains storm surge and why storm surge is so deadly. And you can click on that too on the actual PowerPoint. This is our Saffir-Simpson hurricane wind scale. This is how we measure hurricanes. So you have categories 1 through 5. 1 is 74 to 95 miles an hour. It's still very dangerous and will produce some damage. Category 2 is 96 to 110 miles an hour, is extremely dangerous and winds will cause extensive damage. Category 3 is where we consider it a major hurricane, and we're talking about winds of 111 to 129 miles an hour, and that's devastating damage that will occur. Category 4 and Category 5, obviously very, very dangerous, and those are catastrophic, as we have seen through the Caribbean this summer and in even parts of, in the Keys. The Keys ended up getting hit with that catastrophic damage and that storm surge. So again, if you go back to the last slide here, those YouTube videos will give you the simulations and the models to go with it. And then our last major severe weather that we're going to talk about are winter storms. We don't have them here in Florida, but up north they do. Ice storms can down power lines and tree branches. Blizzards are considered violent winter storms, which are characterized by freezing temperatures, strong winds, and blowing snow. The freezing temperatures can cause frostbite and hypothermia, which are both extremely dangerous, and people can be trapped in their homes with no power and freezing temperatures. So some people could literally freeze inside of their houses, and sometimes the snow is so high they can't even get out of the house. So places up north would face this. We wouldn't, but places up north like New York, Canada, Massachusetts, Maine, areas like that. So that concludes our severe weather lecture, and that concludes our Unit 2 weather section.